student, today we will be starting with a very interesting chapter, and this is based on the mechanical properties of fluids. Fluids means anything that flows. It can be a liquid or it can be a gas. Okay, so today we will be doing with the mechanical properties of fluids, and in this case we will be we will first try to understand the basic physical terms that is related to this chapter, and then again we'll start with the main course, that is viscosity. Now let us first understand what is streamline motion. Streamline flow. Now suppose if we talk about the liquids, then the flowing liquids are considered to be incompressible. What does the word incompressible means? That the density of flowing liquid is constant. There is no change in the density. So when we talk about this word incompressible in the language of physics, it means density is constant. Is constant for that flow. Okay. Now the flow of the liquids in general, it can be smooth or it can be irregular. The smooth flow of liquid is known as streamline, and if the flow is not smooth, that is it is not regular, we call this as turbulent. So there are two things, streamline, and what I said next is the turbulent. So if the flow is regular, smooth, and in simple language, if the particle flows in a liquid in that way that it just follows the path of its predecessor. When the flow of liquid is such that the velocity of every particle at every point remains constant, that we mean that it is steady or streamline. We call this as steady or streamline also. Simply again I will repeat, the velocity of each particle of the fluid at any point is constant, right? It is what we call the streamline. But if it is not, then it becomes turbulent. So turbulent means irregular. The particle itself is not following the same path as its predecessor. Okay, so here what we find, that the velocity is also not constant at every point. So this is the condition for the turbulent. Okay. Now, based on this characteristics, let me just give more ideas about the characteristics of the streamline. Suppose if there is a streamline, it is like that. So if you draw a tangent, it will give you what? It will give you the direction of the velocity of the fluid particle at that point. So a tangent at any point on the streamline, a tangent on any point, this is your tangent at any point on the streamline, gives the velocity of the fluid particle at that point. No, it cannot be like that. Two streamline will never intersect. It is not possible. This is not possible. So if you take another streamline, it can be like this, it can be like this. So they will not intersect, because if they intersect, so this is one direction, this is another direction. So at one point, two different direction is just not possible. So this is another characteristics of the streamline, that two streamlines will never cross each other, because if they intersect, then at the point of intersection, the particles of the fluid will have two directions, and which is absurd, which is not possible only. So we conclude that the two streamlines, they do not cross each other. The streamline means the flow, when it is steady, it is regular, it is smooth, the particles follows the same path as its predecessor. Moreover, the velocity at every point is constant, and if we draw a tangent at any point on the streamline, it will give the direction of the velocity, and the two streamlines will never cross each other. So this is what. Now today we are going to find out a very interesting equation, what we call the equation of continuity. A very simple and very basic equation. This is for hydrodynamics. This is the most important part. Suppose if we have taken a tube, and this is the tube. So this is the area of cross section here. We take the area of cross section another here. Let us assume this is A1, this is A2, and here the velocity is V1, and here the velocity is V2. So the equation of continuity expresses, it is based on the law of conservation of mass. It is based on law of conservation of mass. Okay, and we have taken a liquid flowing in a tube of non-uniform cross section. The cross section should not be same, it should be varying. Somewhere it is more, somewhere it is like that. Okay, and here we have taken A1, V1 and rho 1. So we have taken, this is point A and this is point B. So for point A we have got A1, V1, rho 1 as the area of cross section, velocity and the density. At point B we have got A2, V2 and rho 2. This is the area of cross section, velocity and the density at that particular point. Okay, now we have got the mass of the liquid entering the point A. This is the point A. So whatever mass, density is equals to mass by volume. So the mass of water entering A is what we are getting. Let us assume delta m1 is equals to volume into density, right? So volume is what? Area of cross section into distance. Now when we include the distance, we have got v1 as the velocity there. So let us assume this is the distance divided by time delta t. We assume the time very small, delta t. So we have got v1 delta t for the distance. This is the role of the distance, and rho 1 is the density. Same mass of water leaving, mass of water to leaving B is delta m2, A2, V2, delta T, rho 2. So we have got the mass of water entering A as the same mass of water leaving B. So we can conclude, and moreover the rate of mass, that we can conclude delta m1 is equals to del by delta T is equal to delta m2 by delta T. Now if you take, and moreover the liquid is incompressible. Since the liquid is incompressible, so rho 1 and rho 2 will be equal. If we put everything into this equation, we'll get A1 V1 is equals to A2 V2, or we can write AV is equals to constant. So we have this condition that mass of water entering this point is delta m1 is equals to volume. Volume is area of cross section into distance into density. So we have for mass of water leaving the point B, we have got delta m2 is A2 V2 delta T and rho 2. Since the rate of flow is same, because we have got based on law of conservation of mass, so it is delta m1 by delta T is equals to delta m2 by delta T. So we can make these two equations equal. Moreover, the liquid is incompressible. This simply means the density is uniform throughout its flow. So rho 1 and rho 2 will be equal. So if we substitute everything out here, so we get A1 V1 is equals to A2 V2, and that concludes that AV is equals to constant. So this is a simple thing, that if we increase the area of cross section, the velocity will become less, and vice versa relation. I hope you must have understood the equation of continuity. This is very important. Thank you for watching.